A very good morning to you all. Today we'll be drawing a restriction map for the most common vector, that is PBR322. So there are several ways of doing this, and the tool that we're going to use is NEBcutter version 2.0. You can point your browser to nc2.neb.com, and that will take you here to the home page of this program here. The software that we use here is NEBcutter version 2.0. And if you see here, this tool will take DNA sequences and find the large non-overlapping open-ending frames using E. coli genetic code and the site for type 2 and commercially available type 2 restriction enzymes that cut the sequence just once. So this is important. What we're looking now is not at the open-ending frame, but what we're looking is at the restriction sites and the restriction map that we want to draw for any of the given vectors or any other DNA sequence that you want to put up here, right? The maximum size of the input file is 1 megabytes, and the maximum sequence length is 300 kilobases. So the only limitation here with respect to this tool is that you cannot have a sequence more than 300 kilobases. So, but fortunately for us, the plasmid vectors are not too big. So at max 4 KB or 5 KB. So this will be okay for us to do right here. Okay, so if you see here, there are options for loading the file. So you can have your sequence file that you can load here, or you can give the GenBank accession number that can directly be taken and the sequence can be retrieved at the back end. Or you could paste your sequence here if you have the sequence in let's say, raw format or FASTA format. That can be taken here. I'm sure you know what is the difference between plain and FASTA format. FASTA format will have a greater than sign and one line annotation and then sequence from the second line. Plain format means that the sequence is from start to end. There is no annotation line. There is no greater than sign here. But what we'll do is we'll go the easier way. So what we do is we take this drop-down table here and we select for PBR322. There are other vectors that are given here. You can take any one of them. But for example, here, we take the simplest one, which is PBR322. And then there is an option here to say whether the sequence is linear or circular. So we know that the plasmids are circular, so we click on circular. So this is a radio button. Either one of the two will be on at any given point of time. We want to check for all commercially available enzyme specificities. So we'll click on this here. And then, of course, you can say, you can give an optional name of the sequence. So we are giving it as sequence sequence 1, right? Now we come to here. This is the submit button. You submit the sequence. So here you are. It is now giving you the restriction map for all enzymes that cut once into the PBR322 sequence. So this is a 4361 base pair plasmid. It has two genes, both are meant for antibiotic resistance. So this one is for tetracycline resistance, and this one is for ampicillin resistance. So after you click submit, this will show you a restriction map of PBR322. The total length of PBR322 plasmid is 4361 base pairs, and there are two resistance genes present in PBR plasmid. You have the tetracycline resistance gene, which is shown as A here, and you have the ampicillin resistance gene or beta-lactamase, which is shown as B here. And you can see there are restriction sites both on tetracycline resistance gene as well as on the beta-lactamase gene. And if you see also, the start of the plasmid is taken as the EcoR1 cut site here. And if you mouse over the name of the restriction sites, enzymes, it gives you also the details of the restriction enzymes. So for example, here, this is SSPL, the recognition sequence is AAT, ATT, and it is cutting at 4170 base pairs on the plasmid, and this is producing a blunt cut. Likewise, if you look at, let's say, EcoR1, so if you see here, this is EcoR1, and this is the recognition sequence is GAATTC, cuts at 4359 base pairs, and it produces a 4 nucleotide 5' extension, which means this is a staggered cut enzyme, right? So these are all the enzymes that cut once into your sequence. Now, if you want to see how many enzymes cut twice into the sequence, so you could come to the display menu here, and in display menu, you could come to two cutters. When you click on two cutters, it will give you the list of enzymes on the restriction, on the map of the PBR22, the enzymes that cut twice into the sequence. For example, here, if I mouse over at any one of the enzymes, the other site where the enzyme is present would also be highlighted. So I'm looking at ACU1, and you see the other ACU1 is here. So if I mouse over here, the other one also gets highlighted, and vice versa, right? And also, again, if you see, it gives you the recognition sequence, CTG-AAG, which cuts at 3021 base pairs, and it is producing, again, a staggered cut with 2 nucleotide 3' extension. So this is how you move about. Likewise, you can go for 3 cutters. But then what we want to do is, let's say we want to check a specific combination of restriction enzymes and the size of the product they produce. So you can go here to the main option here, and you can go to custom digest. In custom digest, when you click, it will give you a list of enzymes. So when you click on custom digest, it is going to give you a list of enzymes. Of these enzymes, you can select which enzyme you want to check for in your combination restriction enzymes that you want to check for digestion pattern. So here you are. So let me see. Let's click on EcoR1. So let's click on EcoR1, EcoR5, and Hint3. So this is EcoR1, EcoR5, and let's also go to Hint3 and check. Right? So we have 3 enzymes that we're checking for, and in circular DNA, if the number of restriction sites are n, then you'll get n restriction products or n number of fragments. So Hint3, if you see here, again, if you see Hint3, it also, you have the recognition sequence for Hint3. This is a 6-base sequence, AAG, CTT, and the cuts on the top and the bottom strand happen here, which means this is again going to produce a staggered cut. Likewise, if you look at EcoR5, you have the recognition sequence, which is again 6 bases, GAT, ATC, and the cut happens both in the top and bottom strand at the same position. So this is a blunt cut enzyme. EcoR1 accordingly is a staggered cut enzyme again. So now when you click on digest, this is what you get here. Right? So on the map now, it is indicating the positions of EcoR1, Hint3, and EcoR5. The 0th position on this map starts with EcoR1. So from EcoR1, Hint3 is the next site. And then, of course, you have the EcoR5. And then so how many fragments are going to get here? You'll get 1 fragment that will be between EcoR1 and Hint3. You'll get another fragment that will be between Hint3 and EcoR5. And then you'll have a 3rd fragment that will be between EcoR5 and EcoR1 in this direction here, right? And now if you want to see what is the fragment sizes that you've obtained, so it can directly be derived from here because you already have a map. But to make things easier, you have what is known as Viewjet. So when you click on gel, it will show you the fragment sizes. Also, it will show you how the fragments will resolve on an agarose gel electrophoresis. So you click here, and you can see now this is the sizes of the fragments that you're going to obtain. So it's the range from largest to smallest. So you have EcoR5 and EcoR1. So this is this fragment here until here. Then you have Hint3 and EcoR5. So this is the 2nd largest fragment, and then you have the shortest fragment, this one here. So this is how you basically take it forward. And then on the gel, this is what is being shown on the gel, that how would you get the separation of these fragments on agarose gel. So here is your largest fragment. This is your 4172 base pair fragment. This is the fragment EcoR5 and EcoR1. So this is this largest fragment from this end of the circle until this end. So this is that fragment. Then you have 158 base pair Hint3 EcoR5. So this is your Hint3 EcoR5. And then you have the last fragment, which is 31 base pairs, which is EcoR1 and Hint3. So this is how you can draw, you can predict that given the sequence of the plasmid or given the sequence of the bacteria for that matter, what are the sizes of restricted fragments they're going to obtain. Thank you.